welcome back to the channel. In today's video, we are going to learn how to build a multi-layer perceptron MLP for a regression task using the TensorFlow Sequential API. But this time, instead of using synthetic data, we are going to work with real dataset, the California housing dataset, which is a great example for predicting continuous value like the median house value in California. Let's dive in. So before jumping into the code, let's quickly take a look at the dataset we will be using. The California housing dataset contains information on the various features like the average number of rooms, population, households, and other socioeconomic factors that can influence house's price. Our goal is to predict the median house value based on these features. All right, let's start importing some necessary libraries and loading the dataset. So we'll be using the TensorFlow for building the model and scikit-learn to load the dataset and pandas for data manipulation. So we are importing the sequential data from TensorFlow Keras models to create a neural network and tens for fully connected layers. We are also importing the fetch California housing from scikit-learn dataset to get the dataset and some additional tool for splitting the data and scaling the features. Now let's load the California housing data and take a look at its structure. So this data is a bit large, so instead of manually entering the value, we'll use fetch California housing function, and this will load the data directly. X will contain the features and Y will contain the target variables, which is the median house value. Now we have our data. We need to pre-process it. In machine learning, it's very important to scale the features, especially when using neural networks. We'll use the standard scaler to normalize the features to have zero mean and unit variance. So let's split the data and run the scaling code. So if we split the data into training set and test set using training test split function, reserving the 20% of the data for testing, and then we normalize the data using standard scaler to improve the model performance. Now let's move to the building the MLP model. So now let's build our MLP using the sequential API. The model will have an input layer, two hidden layers, and the output layer. Since we are solving a regression problem, our output layer will have one neuron with a linear activation function. So in this code, we added the first hidden layer with 64. Let's change this to 64 neurons and ReLU activation. We also specify the input dimension using input dimension X-ray shape one, which is the number of the features in the dataset. And the second hidden layer has 32 neurons, and finally the output layer has a single neuron with a linear activation function, since we are predicting a continuous value. Now let's move, and let me run this, and let's move to the next section of compiling the model. So let's compile the model for regression task. The most common loss function is the mean squared error, and we'll be using the Adam optimizer. So we are using the Adam, which is a robust optimizer, and mean squared error as a loss function, which is standard for regression tasks. Now it is time to train the model. We'll fit the training data. Let me run this. We'll fit the data into our training data, especially the number of the epochs and batch size. Let's train it for 15 epochs, and we specify the value 50 here to train the model for 50 iterations, and the batch size is 32, means the model will update the weights after 32 sample. And we also set the validation split to 0.2 to reserve the 20% of the training data for validating during training. As you can see, the iterations are happening and we are almost 35, 36. So it will be total 50 iterations. All right, one more to go. Right, so we have completed the fitting of our model, and now let's do the evaluation. So once the model is trained, we can evaluate its performance on the test data using the evaluate method. So let me run this. This will give us the final loss value of the test data. If the model has run well, the loss function should be low. And finally, making the prediction. So let's use the model to make prediction. For instance, let's predict the house value for a sample using the test data. Here we are selecting one sample from the test set, shaping it and passing it to the model to predict the house value. The model will output a continuous value that correspond to the prediction house value for that sample. And yeah, we got our value. So this is the predicted value. And that's it. We have successfully built a multi-layer perceptron for regression using the sequential API in TensorFlow. We loaded the real data set, pre-process it, build and train the model. And in the last, we have also made the prediction. Yep, this is what is there for today's video. Thank you for watching. I will see you in the next one.